Hi everyone, welcome back to my channel Maths Shala. This is going to be the fifth part of exercise 9.4 of arithmetic progression chapter. Let us look into the problems present in this part of the video. First question of this part of video is going to be question number 12. Further, it has got some sub questions. Let us look into those questions one by one. Question number 12 says find the sum of, first sub question is the first 15 multiples of 8. Is telling us to calculate the sum of first 15 multiples of 8. Let us see how we can do that. It is given that first term a or a1 is equal to 8, which means first 15 multiples of 8. Whenever he is telling 15 first 15 numbers divisible by 8 or multiples of 8, it only means that we need to first form an AP consisting of terms which are divisible by 8. So he's telling us first 15 multiples. It is quite obvious that when he's telling first 15 multiples of 8, it is going to start with 8. Means 8 is the first number that is divisible by 8. So our first term is going to be 8 here. Then whenever it is mentioned multiples of 8 or divisible by 8, like that, in that case always d is going to be equal to that particular number. That is d is equal to 8 in this case. Similarly, I'll apply the formula Sn equal to n by 2 into 2a plus n minus 1 into d. Here we know all the terms that is required to calculate the sum. So we need to calculate sum of first 15 terms that are multiples of 8. Therefore n is equal to 15. 15 by 2, 2 into our first term will be 8 plus n minus 1, that is 15 minus 1 into d is also 8 here. Therefore S15 is equal to 15 by 2, 2 into 8 is 16 here, plus 15 minus 1 is 14, 14 into 8 is 112. Therefore 15 by 2 is equal to 128. 15 by 2 into 128 is equal to S15. Therefore S15 is equal to, I'll cancel out this 128 by 2, I'll get 64. Therefore S15 is equal to 960. Next sub question is we need to find the sum of first positive integers divisible by 3. Now obviously again in this case our first term is going to be equal to 3 and common difference will also be 3, because as I mentioned earlier, whenever we see terms like multiples or divisible by any number, that number itself will be the common difference, and depending on the question they have asked, this a will change. In this case it is first 40 positive integer, therefore a is going to start with 3. Now I need to find the sum of these first 40 positive integers divisible by 3. I'll apply the formula, same formula again, Sn equal to n by 2 into 2a plus n minus 1 into d. Substituting all the values here, in place of n I'll put 40, 40 by 2 into 2 into, in place of a I'll put 3 plus n minus 1, that is 40 minus 1 into d is equal to 3 here. 40 by 2 is nothing but 20, 2 into 3 is 6 plus 40 minus 1 is 39, 39 into 3 I'll get as 117. Therefore, further simplifying, 117 plus 6 is 123, 20 into 123 I'll get as 2460. Therefore, sum of first 40 positive integers that are divisible by 3 is going to be 2460. Coming to the next sub question, let us find the sum of first 40 positive integer that is divisible by 5. Now you can guess that our first term is also going to be equal to 5 and common difference will also be 5. Therefore applying same formula again, then substituting all the known values here, S40 is equal to 40 by 2 into 2 into 5 plus 40 minus 1 into 5. 40 by 2 is 20, 5 into 2 is 10 plus 40 minus 1 is 39, 39 into 5 is 195. 195 plus 10 is 205, 205 into 20 I'll get answer as 4100. Therefore sum of first 40 positive integers that are divisible by 5 is going to be 4100. And the next sub question is we need to find the sum of first 40 positive integers divisible by 6. By now you would have understood completely how we can calculate a and d. Again a is going to be equal to 6 and d will be also 6. Applying same formula and substituting all the values here, S40 is equal to 40 by 2 into 2 into, in place of a I'll put 6 plus 40 minus 1 into, again d is also 6. Therefore S40 is equal to 40 by 2 is 20 into 6 into 2 is 12 plus 40 minus 1 is 39. 39 into 6 is 234. Therefore, S40 is equal to 20 into 246 and S40 is equal to 4920, which means sum of first 40 positive integer divisible by 6 is going to be 4920. Coming to the next sub question, question number 12, which says find the sum of 3-digit numbers divisible by 11. Here we need to find the first 3-digit number that is divisible by 11, that is going to be 110, because we know that 11 into 9 is 99, 11 into 10 is 110. Therefore 110 will be the first 3-digit number that is divisible by 11, and we know that d is going to be same always, that is 11 here, so I'll keep it as 11. Now I need to find which is the last term that is divisible by 11, which is 3-digit. So last 3-digit number divisible by 11 will be 990. We can verify this. Then we can verify this like 110. Sorry. I can take it as 11 into 90, that is 90. That will give me 990. If I take 11 into 91, that will be 1001. That will be the fourth 4-digit number. Therefore, we need just 3-digit number. So 990 will be the last number here. Now using this value of an, I'll calculate en, means total how many terms are there in between 110 and 990. In order to calculate that, I'll take an as 990 and find n. Substituting value for an equal to a plus n minus 1 into d, we know all the values here. I'll calculate 990 minus 110 will be 880, that is equal to n minus 1 into 11. 880 by 11 is equal to n minus 1, or 80 is equal to n minus 1, or n is equal to 80 plus 1. Therefore, A81 is equal to 990, means 81st term of this AP will be 990. Now, I'll need to find the sum of those n terms, that is equal to n by 2 into a plus an. I'll apply this formula. Substituting all the values, I'll get S81 is equal to 81 by 2 into 110 plus 990, or S81 is equal to 81 by 2 into 1100, or 81 is equal to 81 into 550. Therefore, sum of 81 terms will be 44,550. This is nothing but the sum of all those 3-digit numbers that are divisible by 11. Coming to the next and last sub question and last question of this part of exercise, which says find the sum of all those 3-digit numbers that are divisible by 13. Exactly same question as that of previous question, just here we need to find 3-digit number divisible by 13. So given data is the first 3-digit number that is divisible by 13, that will be 104. If you go on telling 13 table, 104 will be the first 3-digit number you will get in that. Now common difference will remain same, 13 always, because whatever I have mentioned earlier, divisible by whichever number is there, that itself will be the common difference. And the last 3-digit number divisible by 13 is going to be 988. This you can verify by considering 1000, because 1000 is the 4th-digit number, so that we will not consider. Coming back to one number, that is 999. Go on checking whether that number is divisible by 13 or no. Then you check with 998, 997, like that you can come back and you will arrive at some particular answer. You can skip in between divisions, and if you are fast enough, you will easily get to this number 988. That is quite easy, and some little bit trick is involved that you need to practice much. Now we know a term, an term. Using this an term, I will first know how many terms are there between 104 first term and 998 last term. For that, I will apply an formula, that is an equal to a plus n minus 1 into d. Now using this formula, I will calculate n value. 988 minus 104 will give me 884, that is equal to n minus 1 into 13, or 884 divided by 13 is equal to n minus 1, or 884 divided by 13 is 68, that is equal to n minus 1, or n is equal to 69. Therefore 69th term of this AP is going to be 988. Now we'll apply the formula Sn equal to n by 2 into a plus n an. Substituting all the known values, I need to find n as 69 here, sum of 69 terms. 69 by 2 into first term is 104 and the last term is 988. Now S69 is equal to 69 by 2 and adding these two terms here, 988 plus 104, I'll get 1092. S69 is equal to 69 into 546. When I multiply these two terms, I'll get S69 is equal to 37,674. Therefore, sum of all those 3-digit numbers divisible by 13 is going to be 37,674. With this, we are going to end part 5 of this exercise, and hope you enjoyed the video. Thanks for watching. I'll come up with new exercise or next part of this exercise in my next video. Thanks for watching once again and have a good day.